where is about an analysis of specimen size conversion in the ductile to brittle transition region of ferritic steels. It's based on the ASTM standard for the determination of the master curve. In this standard, the specimen size effect is explained by the weakest link theory using a three-parameter Weibull distribution with shape and threshold parameters fixed. And the standard permits make size transformation in order to obtain the T0 temperature. In this work, the results for the converted values did not adjust the data in the way the weakest link model predicts. We used the ASTM standard and also a Weibull distribution of three parameters. As I have said, the characterization of fracture resistance in the ductile to brittle transition presents scatter and size and temperature dependence. Since 1997, there is an ASTM standard based on the master curve proposed by Kim Walling, and this standard has been modified over the time, and the last version corresponds to the last year. The master curve is fixed in the temperature x-axis when the temperature of reference T0 is known. For that case, a three parameters Weibull distribution is used with two fixed parameters. The slope equal to 4 and the threshold equal to 20 megapascal square meter. In our work, we use the experimental data of the ESIS, JC experimental values were converted to KGC equivalents, and data values were censored according to the standard indication. Two methodologies were employed, one following the standard with two fixed parameters that we call here MC, and the other using a three-parameter Weibull analysis without fixed parameters. That was named 3PW. Finally, the results were compared. For the MC method, we used values of K0 estimated according to the standard, following that equation, for every size. The K0 values were converted to 1T equivalent according to the following equation that is in the standard. And also, individual data of different sizes were converted to 1 inch equivalent by means of the equation, this equation. And then new K0 values were calculated using this equation. The K0 values were compared to the converted ones and also to those corresponding to 1 inch original. In the second method, a 3-parameter Bible were used, and the parameters were estimated for all the sets with the original sizes. Data sets of different thicknesses were converted to 1 inch equivalent using the normal equation of Bible. Also, the 3-parameter weight of Bible were estimated for the converted sets. And the probability functions were plotted according to this equation for the UT 3-parameter Bible converted, and also for the original 1T set. And also they were compared. Results. We have here a table with different temperatures and different sizes. We have original values, half T, 1T, 2T, 4T. In some cases there were no data, and for each temperature there are the values of K0 calculated from the equation of the master curve, and also the 3 Bible parameters calculated using the usual methodologies of parameter calculation. We can see here values of 1T, and here values converted from half T to 1T, in some case in which the standard recommends to apply censoring, the parameters were recalculated for each specimen. Here we have some values that there were not enough valid data. We can see here that, taking as a reference the values of 1T, we have that the K0 obtained from the size conversions are a little bit different, but they are not very, very different for the master curve. 107, 116, 117, 117. These correspond to 1T equivalent. At higher temperatures, there are more difference: 177, 143, 159, 230. And for the 3-parameter Bible estimation, we can see that the slope is not 4, and also there is differences in the values of K0 for the most of temperature. And we can see that at temperatures near T0, the conversion system works quite well. We have here the original, the probability function obtained from the original 1T test in red for the 3-parameter variables and also for the master curve. We have in black crosses the experimental data of 1T, and in black and also in blue we have the probability corresponding to test in different sizes converted to 1T thickness. This is for original half-T size. We have here more or less the same for original 2T size, and we have here from original 4T size. This is, I repeat, for T very close to T0, or that is at the beginning of the transition. But when we analyze the data corresponding to higher temperature, things were not in the same way. For T equal minus 60 degrees for the 3-parameter variables and also for the master curve, there is an important difference between the original 1T size given by the black crosses with the original in other size, in this case 2T, converted to one size, 1T, using 3-parameter variable and also using the equation given by the STM standard for the master curve. There is also difference between the probability functions obtained for converted values, that for 3-parameter variable are the blue and black curves that are superposed, with the curve for the original 1T size. And in the case of the master curve, the experimental 1T size differ from the probability function used by the master curve. And this situation is common for temperatures higher than T0, including temperatures that have a delta T lower than 50 degrees centigrade, that is the limit imposed for the master curve. Then, the conclusions of the work are that there are some differences, not very large, but there are some. Oh, sorry. There are some differences between the K0 values for when we use conversion of sizes there is no clear tendency in the variation of the three parameters Weibull obtained for different sizes, but they do not coincide. And the comparison of converted values from another size to 1T with the original 1T, there are differences that are large for temperatures that are over T0. In this case, from minus 60 degrees centigrade, or approximately 30 degrees over T0. And then, apparently the weakest link model failed to predict this size effect because probably a problem of loss of constraint. And the censoring of data has a great influence in the shape parameter estimation. We think that there is a constraint effect. That's all. Thank you very much.